I'll do it when we're done. You allergic to it?
Yeah, exactly. I was trying to too. I don't know why because those are not
Any other little things that pop up? We'll find out.
All
Alright, let's go through here. You have a little bit of time to work on the homework since you got the full period. We did the adding and subtracting, multiplying. So hopefully you remember a little bit, but obviously I'm going to refresh your memories. In order to multiply, they got to be the same inner dimensions. Okay. So m by p and p by n, that would work. Those have to be the same. So if you had a 2, let's say I had a 2 by 4 is one matrix and a 4 by 3 is the other matrix, then what would be the resultant matrix, the product? It would be a 2 by 3. Okay, those have to match up, but the outer dimensions are then the answers. So if you take a look at that example there, let's find A times B first. Now I'm going to go through this the whole 9 yards for the first time. Is you don't need to write every little thing out. If you want to, that's fine. But I'm going to go through, like I said, the whole thing here. So A times B, that's going to be 1, 2, -1, 3 times 3, -2, 1, 1, 2, 3. All right, it's going to equal, well, you got a 2 by 2 and a 2 by 3. So in the end, what's my product going to be? In terms of that, Cooper.
2 by 3.
2 by 3. Okay, take first, your last. Coincidence that the second one's a 2 by 3. Now, when we do this, I'm going to kind of write this out. And these are my 6 spots. Do you remember how to multiply matrices, Luke?
I would say just multiply each corresponding number, but.
Okay. So if we're going with that, what do you multiply the 1 by?
Oh, okay. I see what you mean. I don't know.
Okay, fine. Just saying. So here's what you do. Some people think of this as RC, think radio control. It's row times column. Row times column. Take the first row of the first matrix, however big it is, and you're going to multiply it by the first column to get A11. First row, first column. And when you multiply, you go across the row and down the column. And so you're going to multiply corresponding elements and then add if there's more than one corresponding element. So I'm going to show, I'm going to write out the whole thing for the first one. I'm going to take 1 times 3 plus, so you move 1 times 3, then you move over and down, plus 2 times 1. Now that's going to be 5. I'll fill it in here in a minute. I'm just going to leave it like that. 1 times 3 times 2 times plus 2 times 1. So if I want this spot here, this is A12, it's first row, second column. You're going to multiply the first row times the second column. So you're just going to keep sliding down the columns. 1 times -2 plus, you always add, and then 2 times 2. Okay, for that. And then A13, first row, third column. So you're going to multiply that first row, column by column by column. 1 times 1. Plus 2 times 3 for that. Now, to find your next row, you're going to move down to the row of the original one here, -1, 3, and you're going to multiply that by all 3 columns. Okay. So the number of elements in a row must match the number of elements in a column. That's why the 2 middle dimensions have to match up. So you have the same number to multiply. And so this one's going to be -1 times 3 plus 3 times 1. And that is A21, second row, first column. And then we're going to go A22, which is -1 times -2 plus 3 times 2. And then A23. And what do I get there? A23. I got -1 times 1. And then plus, what do I got there? 3 times 3. Now, when you get a little bit better now, you just kind of do it mentally and put it down. If you need to write it out, fine. Doesn't matter. But in the end, what do I get here? 5, right? 5. And then I get -2 plus 4, which is 2. 1 plus 6 is 7. -3 plus 3 is 0. 2 plus 6 is 8. -1 plus 9 is 8. We agree? All right. Row times column. Row times column, all the way across. What's B times A equal? Okay. So let's take a look at B times A. Cooper, what's it equal?
No solution.
Yeah, we'll say undefined.
Undefined.
Undefined. Say no solution for an equation for this. So now I'm going to write it out. So what do I got? 3, -2, 1. 3, -2, 1, and then 1, 2, 3. Just to kind of talk about it. 1, 2, 1, 2, -1, 3. All right, here's your issue. If you do row times column, how many elements are in the first row? There's 3 elements in the first row. How many elements are in the first column? 2. So you can't move all the way across and down and have everything match up. So that's why those middle dimensions have to be the same. So this is a 2 by 3. This is a 2 by 2. Middle dimensions are not the same. So this is not defined. Now that leads us to actually a pretty big statement. A times B cannot equal B times A, right? We just did A times B. We got an answer. B times A is undefined. So that means that for matrix multiplication, it is not commutative. Okay? A times B does not have to equal B times A. Now, it could. There are situations where it does equal, but the vast majority of the time it does not, and it does not have to equal. So it is not commutative. Some properties of matrix multiplication. So A, B, and C are matrices. C is a scalar. Okay, you got to assume that each product is defined. Okay, so there's nothing that's undefined. The associative property will hold. If I do multiply A times B first and then times C, I'll get the same answer if I multiply B times C first. Okay, and then the distributive property will hold whether the matrix is on the left or the matrix is on the right. You can distribute a matrix. And then that's a scalar here. It doesn't matter whether you multiply it by the A first or the B first. It gives you the same thing. Okay. All right. Now, on that next page, you should have A and B there. You really got to watch because
Sorry.
your instincts, you got to watch your instincts for squaring something because it will be incorrect. And I'll show you here in a second. Go ahead and add those two together like you normally would. And so I got A plus B is going to equal 2, -3, 4, 1 plus -1, 2, 5, -6. And when I add those together, here you just add corresponding elements. 2 plus -1 is 1. -3 plus 2 is -1. And then 4 plus 5 is 9. And then 1 plus -6 is -5. Okay, for that. Right, to square that, you do not just square the individual pieces. Okay, that does not work. So you got to be careful there. And to square that, let me see if I can move this up a little bit. There we go. Okay, if I'm going to take this 1, -1, 9, -5, and you square it, you got to follow the definition of squaring. Definition of squaring means you multiply it by itself, right? So I'm going to have to write it twice. And so I got 1, -1, 9, -5 times 1, -1, 9, -5. And you got to do row by column. row by column. Okay, and that's gonna give you a different answer than if you just square each individual term. So think about this, they're both 2 by 2, so my answer is gonna be a 2 by 2. So first row times first column. 1 times 1 is 1, -1 times 9 is -9, gives me a -8. All right, see what you get for the other three. See, this is, we're okay there on multiplying. I do. Yeah. Okay. Thank you, calculator. Okay, yes, I got it. Yes. Hey, we got guided notes. We got notes. Huh? I wonder if Nathan, what you got? You got this? You know what you're doing?
Yes.
What you got?
-8,
Okay.
and then 4 for that one to the right. And then bottom left is -36.
Okay.
And then 16 for the last.
16. I agree. 1. We did the first one. 1 times -1 is -1. And then that gives you a +5. -1 plus 5 is 4. Move down to row 2. 9 times 1 is 9. That's going to be -45. So this is 9 minus 45, -36. And then -9 plus 25 gives you 16. So you make sure you add first, and then you just got to watch because you want the tendency you just want to square all the individual terms. That will not work. Now, the second one I want to take a look at is similar to that. Hold on here. Same two matrices, but a squared minus b squared. Okay, a squared minus b squared. All right, when do you do a squared? When do you do b squared? Okay, when do you do a squared? When do you do b squared? And then how to share with each other if you trust who you're working with.
I trust you wholeheartedly.
Wow.
I believe in you.
Minus.
-8, -9.
There we go.
I got 11, -14, -35, and 43.
See, that's interesting because
Wow, Cole.
Did you get
What'd you get? 11
He's do the thing.
over -14.
Yes, he's do the thing.
And then -8.
Yep.
And then I got -8, -9,
Exactly what I did.
-11.
Just differently.
All right, Mackenzie, give me one of them.
I did a squared.
Okay, what do you got?
-8, -9, 12, and -11.
All right, so let me step back here. 4 minus 12 is -8. -6 minus 3 is -9. 8 plus 4 is 12, and -12 plus 1 is. I agree. I agree. Emily, you got B, or does Audrey?
Aubrey.
Aubrey.
I got 11, and then -14, and -35, and 46.
46. We agree? Okay, now you just gotta subtract them. Okay, now you gotta square first. And so -8 minus 11, -19. -9 minus -14. 12 plus 35 is 47, and -11 minus 46, -57. All right. Now, when you are doing something like this, okay, now you have to know how to do this without your calculator, but if you wanted to test or if you wanted to check things, you could type in your matrix. So a 2 by 2. What was matrix A? Let me just look that up real quick. 2, -3, 4, 1. So 2, -3, 4, 1. And if you want to do any operation with it, you have to hit the matrix menu. And then from the names, you would hit A. And if you want to square, you can hit A squared. So you get -8, -9, 12, -9. So you can use your calculator. Will be times I want you to use your calculator, but you got to know how to do it without it as well. Okay, for that. But that would be a double check. All right. Obviously, you got extra time because the other classes are short. Go ahead. A couple of these have a couple pieces to them, so get this done here, or as close to as you can.